All right, today is Unit 2, Day 5. We're going to do absolute value functions and the graphs of those absolute value functions. So learning target, I can graph absolute value functions with transformations and stretch and compression. Okay, so the absolute value of a number is the distance from zero. So I think a lot of people just think of it as if it's negative, make it positive. And if it's positive, leave it positive, and that's kind of like the middle school definition, I guess I'd call it. But we're really looking at how far is it from zero, the number itself. So like -3, how many units from zero is that? That's 3 units away. -2 is 2 units away. -1 is 1 unit away. And you can't be a negative distance, so these have to all be positive numbers. 0 is no units away from 0, and then 1, 2, and 3, those are kind of easy. So now, what we want to do is we want to graph this guy, and then I want you to memorize the shape of it. We want you to memorize the shape, and then we're going to do some moving around with this. So if you plot these points here, -3, 3, -2, 2, -1, 1, 0, 1, 1, 2, 2, and 3, 3, kind of see a pattern here. So if I kept going with this and I plugged in 4, the absolute value of 4 is 4, the absolute value is 5, 5 is 5, and so on. It's going to make a straight line going this way. Okay, missed there a little bit. And then go in the other direction, same idea. Like if I went -10, that'd go up 10. -7 would be up 7. So it's the same idea. It's just going the exact opposite. And kind of the one way, look at the slopes of these guys. Going this way, it's a positive 1 slope, up 1 over 1, up 1 over 1. Here it's a negative, so up 1, left 1, up 1, left 1. It's kind of a -1, so -1 slope, positive 1 slope. And it makes a V shape. To get this V shape out of it, a V shape centered at 0, 0. We call that the vertex. Maybe you've heard the word vertex before. In geometry, a vertex is a corner. In algebra, it's a turning point. So kind of same idea. So that's the vertex. Vertex is at the origin. That's the parent function. Okay. The graph is symmetrical about a vertical line called the axis of symmetry. And a single minimum point called the vertex. We said that vertex. This is also known as the absolute value parent function. Okay, so the parent function. Notice the graph is actually a piecewise function. Okay, so we've been talking about piecewise function. It's actually, if x is less than or equal to 0, it's x. I'm sorry, greater than or equal to 0, it's x. Going this way. If it's less than or equal to 0, it's just a negative slope. They both have a y-intercept of 0. It's not written, but it crosses at 0. The equal, you could put on either one. You could slap the equal on here, and it would mean the same thing. At the bottom here, nearly all variations can be made by starting with this V shape, and then just making some slight adjustments, like sliding it up, down, left or right, flip it over, widening it, and shrinking it. That V shape, but it's going to be the basic starting point is a V shape. So let's look what happens on this one when you have a -4. Now notice the -4, it's not inside the function. The absolute value function is there, and then we're going to subtract 4 off the end. So basically what's going to happen is we're going to take all of these y values, because this is the absolute values. When I plug in -3, I get 3. When it says -4 on the end, you're going to subtract 4 from this number. So really all these answers are just getting 4 less, which means their y values are 4 less, and the whole graph moves down 4 units. Okay, so if I plug in -3, the absolute value of -3 is 3. 3 minus 4 is -1. If I plug in a -2, I get a -2. If I plug in a -1, -3. 0. 0 minus 4 is -4. 1 would be -3. Now we're coming back up. We're increasing again. Okay. If I plot these points, -3, -1, -2, -2, -1, -3, 0, -4, and so on, I get this V-shape one like this. And it's just, I said, all those y values from the previous table above, all these y values lost 4 units. So instead of being at 0, it's down at -4. Instead of being at 1, it's at -3. So the whole thing just got moved down 4 units. And that's what I have here. Still a slope of 1 on the right side because we didn't change that slope at all. Still a -1 slope on the left side. Okay, so what difference do you see compared to the parent function? Well, the vertex was translated down 4 units. Okay, so the vertex and everything else was translated down 4 units. Okay, the slope stayed the same. We can say the slope is still 1 and -1 depending on what side you're on there. So the slope didn't change at all. Okay, now flipping it over, let's look at what happens when the number's inside. So this is inside the absolute value with the x. The one on the other side was y equals the absolute value of x minus 4. So you subtracted after you did the absolute value. Here we're going to add before we do the absolute value. So it is going to be a shift. It's going to be, instead of changing the y, it's going to be changing what x values. So here, when I plug in -3, I got -3 plus 2 is -1. What I'm actually taking the absolute value of is -1, not -3 anymore. So that's why if you put it inside here, you're changing the x value that's being absolute valued. You're changing the x value that's actually doing the whatever the operation is. In this case, we're doing absolute value. We'll do some square roots and squares in the next few days. But this actually changes which x you're doing the operation to. So I'm actually, instead of doing -3, I'm doing -1. The absolute value of -1 is 1. When I plug in -2, you're going to add 2 to it first and get 0, and then take the absolute value of 0. So you're not taking the absolute value of -2 anymore. You're taking the absolute value of a different x value, 0. Okay, and it kind of goes like this. I'm going to fill these in like that. And like I said, if you ever need to make a table, just go ahead and make a table if you forget. But we want you to just memorize these tricks. Okay, so -3, 1. So -3, 1. -2, 0. -1, 1. 0, 2. Kind of see a pattern here all the way up to 3, 5. And it looks like a check mark, but if I continued it on, I guess going this way, it's going to be going that same pattern, still a slope of 1. But here's this check mark, and it stops right here. Well, if I kept going, if I plugged in -4, add 2 to it is -2, take the absolute value as 2, it's still going to follow that same pattern. It's going to be that same V shape. So the V shape doesn't change, but what did change? So what difference do you see? Well, the original parent function was right here, had a V shape right here. This one shifted 2 units to the left. So the vertex and the axis of symmetry, so the axis of symmetry, translated 2 units to the left. So translated 2 units left, which this kind of throws some students off because that was a plus. Plus made it go left, and you would think plus would be right, but it's kind of the opposite of what you think on that one. I apologize for this. This graph should have been moved up so that this parent function question would be right here. Something happened when I copy and pasted this, but because I copy and pasted from my individual files into one big file, and sometimes this happens with the margins or something. But yeah, so a plus inside means left, whereas on the front side, a minus on the outside meant down. It's what you thought it would mean. Here, though, this is the opposite of what you mean. So you got to remember, opposite, if it's on the inside, it's the opposite of what you think. Okay, so let's do some practice here. So if I was graphing this guy, it's on the outside. On the outside is up and down, and it is what you think. Positive should mean up, so it's going to go up 3 units. So I'm going to take this graph. I don't want to make a t-table every time. I don't want to waste my time doing this. We're just showing you, discovery kind of stuff. Like, look what happens. On this guy, I'll just make a V shape, and I'm going to move it up 3 units. So I'm going to take my vertex up 3 units, put a point, and then there was no left or right movement. There was no slope change. So I'm just going to go slope of 1 to the right, slope of -1 to the left. Okay? This guy here, it's inside the x with it, so it's left and right, left or right, and it's the opposite of what you think. So you would think negative is left, but it's actually right. So we're going to go right 5 units. So I'm going to take my vertex, which was at the origin, and go right 5 units. 1, 2, 3, 4, 5. And then from there, slope of +1 on the left side, slope of -1 on the right side. So pick a point out here. And put some arrows on the ends because it does keep going. These graphs don't ever stop. They keep going up forever. And then this guy here, I've got two things going on at once. It's both of these. So I'm going to go up and I'm going to go right. So I'm going to go up 3, and then I'm going to go right 5. So and it doesn't matter what order you do this. Okay, if I went right 5, then up 3, I'm going to land at the same spot. So start at the vertex, go up 3, right 5. Again, I could go right 5, up 3, doesn't matter. I get the same spot both ways. Slope didn't change. We haven't even talked about slope yet, how slope changes, so we're not going to worry about that just yet. And do a slope of 1. Okay? So just kind of reviewing down here, and this is, here's our parent function. We use h's and k's. We use h's and k's. So if it's inside, we call it an h. And if you notice, it says like if h is greater than 0, which just means positive, then a minus means right, opposite of what you think. Okay, opposite of what you think. And then it says as long as h is greater than 0, so as long as h is a positive value, if you have a plus, plus is left, opposite of what you think. Okay, so the opposite of what you think. But here, if it's outside, we call it k, and we're just saying let's leave k as positive in both cases. If it's a positive, it's up, which is what it should be. If it's negative, it's down. So it is what you think. So not the opposite, it is what you think. Some reflections here. So these are just building off these. I mean, we can make t-tables and show you that this is true. Hopefully you trust us by now, or hopefully you trust me by now. A reflection, if I have a negative out front, that's going to flip the whole graph over this way. So it's going to flip about the x-axis this way. If it was a negative inside, it's going to flip it this way, about the y-axis. Okay, so keep that in mind. And then out here, we keep saying the slope didn't change. The slope didn't change. Well, here's where the slope does change. Just kind of keeping it simple here. There's a different way of teaching this, but I think since I'm only going to be doing vertical stretch and compression, if a number is out front, if you notice all of these up here, there was no number out in front of the absolute value. So it was a 1. Okay, so the slope was 1 and then -1 on the left side. If we change that, if it is greater than 1, we call that a vertical stretch, which means it's increasing. Instead of being this, it's going to be like this. It's going to increase it vertically. It's going to stretch it vertically. And it is that's the slope. So if it was a 3, you'd have a 3-to-1 ratio of slope. If it's between 0 and 1, which just means that it is a decimal, a fraction, less than 1, then it's going to be a compression, which means instead of this going at a diagonal, it's going to be more like this. It's going to vertically compress it down. And the cool thing is, whatever that number is, that's the slope. So if it was a 1/2, it'd be up 1 right 2, up 1 right 2, which we'll do some with over here. Here we got some vertical stretch and vertical stretch. So first off on this one, I see +3 on the outside. Again, if it's on the outside, it's up and down, so that is an up 3. And I see a negative, which means it's going to flip. So flip, and it's on the outside, so that's about the x-axis. That's going to flip it this way over. Okay, so move that first. We're going to move this guy first. We're going to go vertex, go up 3 units. Now instead of making a V shape this way, we're going to make a V shape this way. It's going to flip it over. It's going to take this and go flip it that way. So it'll be a -1 slope on the right side and a +1 slope on the other side. So it looks something like that. This guy here, no translations. There's no plus or minus inside, no plus or minus on the inside. So the vertex is going to stay right where it's at. It doesn't move. But I see this vertical stretch of 2, which just means instead of going up 1, right 1, now it's going to go up 2, right 1, up 2, right 1, up 2, right 1. And same thing on the other side, up 2, left 1, up 2, left 1. And I'd say if you absolutely forget, if this is a test or a quiz, and you say, gee, I don't quite remember what's going on, so make a t-table. You could just flat out make a t-table of this guy, plug in some value, -3, -2, -1, see what happens. But it's just going to make life a whole lot easier if you do have it memorized. Okay, this guy, a whole bunch of stuff going on here. So I've got a +3, I've got a -5. +3 means up 3, minus 5 means right 3, opposite of what you think. I'm sorry, 5, right 5. And then you got a negative, which means flip. And you got that 2, which means slope is now to a negative 2 instead. So we're going to do a whole bunch of stuff here. We're going to go up 3. We're going to go right 5. 3, 4, 5. There's my vertex. Instead of going up, I'm going to go down because the negative, and then it's going to be down 2, right 1, down 2, right 1, down 2, right 1, down 2, left 1. And look like this. Okay, originally the other one was not quite as steep going down. Okay, it was more of a 45-degree angle. So yeah, just a lot of, it's almost like a game, and maybe not a fun game for you, but it's almost like a game. Just follow the rules, flip, move, slide, and you'll get it right.